Hello, everybody. Good afternoon. Do not adjust your TV sets. This is not Gordon. Gordon is away this week. My name is Jay. I'm the developer relations manager here at the World. And with me is Jermaine. What is your role officially?
Hello, my name is Jermaine. Thanks, Jay. Thanks for the introduction. So my role officially is 3D artist at Anything World. So basically what I do is everything that title says, up to 3D art, pretty much animations, character design, environment design, stuff like that. Pretty much all the fun stuff that you see about it. I've been involved in some kind of way. So that's my role.
That's the major closing out of the part. Make comments about it. So today is a historic event. The music is a bit loud. Okay. I'm going to set the music a little bit lower. Is that okay? Is it better? Is the music better? Anybody confirm in the chat, please?
Can you not hear the voices?
Can I hear the voice?
The voices gone.
Somebody said yes. Okay, I'm gonna put the audio way lower, and I hope you can hear me now. Can you hear me now? No? Oh dear. Let's put the mic up. Okay.
Better, worse?
Is it better? I mean, I let people know on Twitter that I'd be fumbling with streaming software, so, you know. Okay, perfect. Thank you, Sandy Lane. Great. So, today's a historic event because it is the first of a series of streaming sessions where we'll be developing a game using Anything World and Unity. So, a little bit of background. The idea for this game, it started when we were in Brighton for develop, and a seagull tried. I'm not sure if it succeeded, but at least tried to eat Gordon's chips.
This is definitely a rumor spread around by Gordon. I think it's a conspiracy theory that Gordon is paranoid about seagulls, so he's forced us with a pitchfork behind our backs to actually start making a random, pointless seagull game.
Yeah.
So thanks Gordon for giving us this task of researching seagulls. We can be doing other things with our day, like I said. We're going to be researching and designing games based on seagulls.
Yeah, and today during the stream, you will help us judge if seagulls are evil or not. We're gonna have some facts about seagulls, and you'll decide on the chat if seagulls are horrible monsters or just friendly animals. So anyway, the idea came from Gordon and seagulls, and it was born as the Seagull game, and we were brainstorming internally, discussing how it should be. And I was speaking with Jermaine, I think last week or the week before that, and I gave the idea of turning it into a Katamari Damacy-like clone. For those of you who don't know Katamari, it's very weird. It's a very weird Japanese game where you have to simply pick up stuff and make this massive ball of matter, basically. So the idea of the game is going to be you're a seagull, you're going to be flying around, and you'll be able to eat stuff. And the more stuff you eat, the bigger you get. The bigger you get, you can eat bigger stuff. So you can start being able to eat, say, a hamburger, and then you get a little bit bigger, and then you're able to eat a large meal. And then when you eat the large meal, you get bigger, and then you're able to eat, I don't know, a chair. And then you'll be able to eat a table and people and cars, and it's going to be crazy because Katamari is a pretty wacky game. But I'm talking too much, so let's get started. So we'll start with setting up Anything World in Unity, so you can get to know the process from the start. I am going to switch again, fumbling with streaming software. There you go. So we are going to start at the Unity Asset Store, and I'm going to search for Anything World, and I find our plugin at the Asset Store called Limitless Animated 3D Models by Anything World. We are a Unity verified solution. We've been available in the Asset Store since last week, and I have downloaded it already. I have added it to my account, and it's free. So if I click on Open in Unity, I am thrown into Unity, into the package manager, and since I already have it on my assets, I don't need to download. So if it was your first time, you need to download it. I've already did, and I'm going to click Import to import it to my project, and then confirm. Import again.
So what are the main uses with Anything World?
Right.
Once you get it, what should you expect while you're going for this downloading process?
Yeah, absolutely. Yeah, very good, Jermaine. So what Anything World offers today is what we call the Anything World browser, which is a collection of 3D models. I think we are at around 200 3D models, both animated and still, that you can use in your game. And the animated models, they were animated by our AI agent that takes a static 3D model, rigs it, and provides you with a set of basic animations like idle, walking, running, and jumping. So once you've imported the Anything World package, you're going to need a few more, actually 3 more packages in your project. So I'm going to go to the Unity registry here, and I'm going to look for the Universal Rendering Pipeline. Universal RP, and I'm going to install it in my project. And so our AI agent, it rigs and provides animation, and in a few weeks time we'll be launching a service where you can upload your own 3D models and your own static 3D models, and we're gonna rig and animate them for you.
So what is this universal render pipeline? What's it good for? Like, do I need it? Does it give me more seagulls? We need seagulls. We need buildings.
Right. So
the universal render pipeline.
Yeah, the seagulls and buildings are going to be in the browser. So the universal render pipeline is a feature that Unity launched a few years ago basically no two games are alike, especially when we talk about different platforms, right? Your rendering needs for a console game is very different from the rendering needs on your mobile game. And before the rendering pipelines, Unity had one default way of rendering that was pretty much one size fits all. But again, depending on the platform, depending on the style of the game, it may be overkill or underkill. So Unity came up with rendering pipelines, which are a way to customize the way Unity renders your game, and then you have more freedom to create a more complex pipeline in case of, say, of a high-end AAA game for the latest generation of consoles, or something simpler for a chess game on mobile.
So I'll have super colorful seagulls, I'll have super colorful skyboxes. Is that what we're talking about here?
It not out of the box, but it allows you to create that if you want,
Okay, that's cool. I'm down with that.
So other than that, we also need the Newtonsoft JSON package, which is not available on the Unity registry, so we would need to download it from a Git URL. I'm going to package manager. I'm going to paste the address of this Git repository for Newtonsoft JSON. And this address, don't worry, it's on our documentation, so you just need to copy and paste it and click add. And there you go, it's importing, and that's essentially just a JSON parser, because some of the information on the models within the Anything World browser is in a JSON file, so you need to be able to read those. So we're almost done with setting. We just have a couple more steps to go. There you go, the Newtonsoft JSON is imported. And the next do history here. And the next thing, I'm just going to go to my project settings, and on the graphics session, you have this scriptable render pipeline settings. Again, we're talking about render pipelines. You're able to create your own setup, your own configurations, and when you import the Anything World package, we already have a configuration ready for you. So all I need to do is import this universal render pipeline asset, which again is provided in the Anything World package, and you can and you can open it and customize it if you need. Sandy's asking, can I find a guide to find a guide to setting up somewhere? Absolutely. So on the asset store page, you have some videos explaining how to set up. They are narrated by a very handsome fellow. And also on our website, you have on the documentation, you have the Unity Quick Start Guide, and also we support Unreal. So clicking on Unity Quick Start, you have all the setup requirements right here. So back to Unity, and one last thing I need to do to set up is I have here a list of the shaders that are included in Unity. So in a very, very small thumbnail, what is a shader? A shader essentially is a piece of code that tells the game engine how to render a specific part of your 3D model. So a very basic shader can simply tell, just reflect the light and be done with it. And you're going to see the color of the object. So if it's a red object, the light's going to bounce on it. You're going to see red. But you can do very crazy stuff like holographic effects, black and white. I don't know. Tell us about a crazy shader you can do.
Yeah, you can do some pretty cool stuff with shaders from what I've heard. You can make skyboxes with shaders. You can use shaders to make super shiny or super sparkly textures. It's actually really cool. I want to use it to make some lasers come out of the seagull's eyeballs at some point. Or maybe even when the seagull needs to go toilet, we can have a toilet shader that comes out, or something, I don't know, something crazy, poop shader, maybe, who knows. So yeah, that's something I think like we can use down the line with shaders. Like I've got some cool ideas for it.
I was reading about the other day on Twitter a very long thread talking about how the footsteps on the snow effect on Red Dead Redemption 2 was made, and I mean that was way above my head. But shaders were involved in it. Shaders were part of it. So so it's essentially shaders are crazy.
They're everywhere, man.
Yeah, they're
Kind of
everywhere.
like aliens.
Exactly, and seagulls. Okay, so the last step, as I was saying, shaders. You just add the 4 shaders that we again are provided in the Anything World package. So you add them to the list of built-in shaders in Unity. That means that when Unity builds your game, it is going to include these shaders in it. And that's it. So now we are ready to start using Anything World in our game, in our project. So if I just close this project settings window, over here in the top left corner on my screen, I have the Anything World option on the Unity menu. I can click on it, select Anything Browser, and I'm going to log in with my username and my password, 123456. I'm gonna click login.
Tell them your password.
That's okay. It's my bank password as well, so it's all good. And then you have access to the Anything Browser, where you can the browser where you can browse all the 3D models that are available in our catalog. With that, we are ready to get started, and I'm going to start by first of all switching to a project that we have already a little bit in progress, which Jermaine have created the basis of the environment. He's going to work on it in the second part of the stream, but he already made the basics of these trees and the road and the skybox and the seagull, the very, very bare bones basics. And from here, we will start with the logic of the game. And on this first session of the series, we are going to do the basic input for the seagull. And one thing that's different, and I noticed that when you look for Unity tutorials or Unity content on the internet, there's a lot of stuff, right? It's Unity have a massive community. There's a lot of people creating content for it, and I have never seen any tutorials, any content using Unity's visual scripting system. So we've decided to do this series and this session using Unity's visual scripting, and hopefully, it's not going to blow in our face. I think it won't. I mean, we've played around with it. Well, full disclosure, Jermaine played a lot with it, and I think it is pretty solid, right?
It's a ticking time bomb. We don't know when this is going to blow up. We don't know when it's going to, cave in on our heads, but we're ready for it. We're ready for it, man.
Yeah, I mean, worst case scenario, we're going to give the people at home a good thing to laugh about, right?
Yeah, exactly.
So I am going to start by selecting our seagull model, and I am going to add a component to it called, it's not, it's Script Machine. Did it work? Yeah, there you go. So the Script Machine is the basic component to use visual scripting on Unity, and we're going to create a couple of scripts, visual scripts for a seagull. The first one will handle the input, and our seagull is we're going to rotate it using our mouse movement, and we're going to use WSAD, well, actually only W, right, to make the seagull fly forward. So I'm going to create, I have the source for the Script Machine is going to be a graph. A graph is basically what in Playmaker is called an FSM, and in Unreal Blueprint is called a blueprint, in Unity it's called a graph. I'm going to create a new one, and I'm going to call it movement Rotation portrait. There you go. Rotation.
Fancy.
Yeah, I know. I mean, it's important to know how to name stuff. So I'm gonna open my graph. Come on. So I'm gonna launch as it opens. I'm gonna make the first question for the audience, and I said that we're basing it on a game called Katamari Damacy, which is a very weird game, and it's a game I like very much.
Yeah, how did we? I know this was part of the brainstorming session, and we were talking about some other ideas as well in that brainstorming session. The video is going to come out soon. We got a whole recording of like how we came up with this idea, what sort of stuff we can add, the conspiracy theory that Gordon believes about seagulls, and all of these other elements that are part of this whole game design process. But the main thing I think I heard me and Jay talking about was scope, making sure that whenever you're making a game, make sure you don't. Scope is basically an idea of how big is your game going to actually be. You know, how complicated is this thing going to actually become further down the line. With visual scripting, it makes it a lot easier to create things like game mechanics, but you can also end up with a whole stack of noodle-looking ideas that you've put down, scrubbed away, forgotten. So you have to give yourself some scope to keep things neat, tidy, make sure that you don't, just run away with your own imagination. And that's what we kind of did with our brainstorm. But what are some of the main points that you think we came back with from that brainstorming session? I know, for one, the Katamari game sounds cool, making the seagull get bigger. I think there were some other things like getting the seagull to poop. What was another one?
The seagull to poop. Yeah.
Seagull pooping.
Yeah, we went to add seagull pooping to the game, and we're not sure exactly what that should be. So if you have any ideas, what should happen when our seagull poops on something, let us know in the chat. Be part of the design process of this game. And can the seagull go toilet? Absolutely. Please add the seagull.
Yeah, maybe a public toilet, private toilet. I don't know.
Yeah. I mean,
yeah. We need ideas. This game needs to become epic. That's what we're looking for, epicness.
Actually, before I forgot to show it. I have a few screenshots of the Katamari game, just so you get an idea of how the game works. So, just gonna show real quick. So, this is one of the first levels of the game. So, you'll control this little guy here, this little green guy, and I think this is the first level. So you're rolling small stuff, like you can see a coin, a thumbtack, some gum, and it starts pretty tame, and then the balls, the spheres get bigger and bigger. So on this one, you can see that we have rolled some people into it. Like there's two girls, there's a lady, and you can see that small green smudge here. It's the green guy from the first image. So the spheres are getting bigger and bigger, and then finally you get to the point where you're rolling trees and balloons and buildings. There's a giant squid here, and so again the levels get bigger and bigger and crazier and crazier. This is what
should the seagull eat people? Are we sticking to ethics here, or are we?
I think
are we going a bit rogue on this?
I think it should eat people. I mean,
people,
why not?
Cars,
people, everything that works,
anything
buildings,
that moves, basically, and doesn't move. Everything. Period. It's like this is going to be Colossus. I don't know who's going to be able to stop this seagull. Maybe Godzilla. Maybe giant aliens.
Yeah, everything.
Maybe a giant Gordon. Maybe that's the final boss.
Oh, I like this idea.
But send us your ideas, guys. We definitely need some of your cool ideas.
We need to attach something to the action of the seagull pooping. We need to figure out what that means in the game.
And also, if you've got any ideas for how you want the scene to be designed, anything that you want to see in the background, maybe a cool nod to some sort of game that you've played before, anything, just let us know. We should have a model of it in Anything World. If not, you're out of luck, I guess.
Sandy's asking, how big will the seagull get? Big. Yes, very, very big. We don't know yet the limit. The sky's the limit.
Yeah, that's up to you guys. You tell us, how big should this seagull get?
Oh, look at that. Instead of seagull eating innocent people, it can stop street fights against two globbies. Yeah, we can have globbies in the game, for sure. Somehow. We should incorporate globbies somehow. So anyway, so back to our visual scripting, right? So I've created get back to the monitor, there you go. So I created the graph, and if you're familiar with Unity scripting, when you create a new C# script, you get an on-start and on-update events, and you get the same on visual scripting. Now, we are not going to need the on-start event, so I'm going to delete it, because we will only rely on the on-update event. And so again, what on-update means, it means that whatever we put here connected to this event is going to happen every time we redraw our screen. So I'm going to start creating 3 variables. And to create variables here, I have this graph variable section on the left. Oh, I'm going to create a variable called vertical turn factor. And this is going to be a float with a value of 1. I'm going to create a new one called horizontal turn factor, also a float with a value 2, and a speed. No, let me be consistent with my capitalization. This should be an H. Also a float, and I'm going to value this to 0.05. So in a nutshell, what these variables do, they're going to control how fast our seagull is going to turn, up and down, left and right. I know there's the proper term is pitch, yaw, and roll, but I'm not exactly sure which one is which. So just horizontal turning, vertical turning. So this is going to control the speed of this rotation, and the speed variable is going to control how fast the seagull is going to move forward. Great. So now I'm going to start to get my input from my mouse and from my keyboard and apply this on my seagull. So I'm going to start by right-clicking on my graph, and I'm going to look for input. What was that? Was axis, right? Yeah, input get axis. And here I have to set the axis name. I'm going to call it input Y, because by default Unity have several configurations of input, and these are defined by what I call axis, and the Y-axis is the one that gets the input on vertical movement of your mouse. So I'm going to get...
somebody's saying maybe you can add some buildings so the eagle can eat it. That's coming up.
Yeah,
that's coming soon.
That is coming. So I'm going to get the Y input, and as you can see, I've dragged a line from my on-update event. That's the cool thing about graphic programming. It's very easy to connect stuff and to build stuff, especially in comparative programming. This is coming from a programmer. I'm a so-so programmer, but it's so much easier to do stuff on Visual. It's amazing. So I'm going to repeat this get axis. So I just copied and paste this node, and now I'm going to get the input X, which is the horizontal movement of the mouse. So I'm going to get these 2 pieces of information from my mouse movement. Next, I'm going to get this information, and I'm going to call a function called multiply. And what I'm going to do is I'm going to multiply my y-axis information with my vertical turn information. So this variable that I've created here. So I'm going to right click again, and I'm going to create a node called get variable. What's the name again? Get graph variable, and I'm going to select here my vertical turn factor, and I'm going to apply this on this multiply. And again, as I said, this turn factors is going to define how fast our our Seagull is going to turn. So I'm going to multiply by that, and I'm going to do the same thing for my X input, but now with the horizontal turn factor. There you go.
So in the chat, let us know how fast you want our bird to go.
Oh yeah, true.
Is it going to be super bird? Is it going to be slow bird?
Yeah. Good. Yeah, that's good. I mean, we have like I've defined these values because of tinkering, of course, for the stream, and these values made sense to me. But again, let us know what you think. Don't be mean with us. Don't suggest horrible, crazy stuff. But yeah, now after I multiplied, after I applied these values, I just want to make sure I don't get a super fast or a super slow rate of turn and movement. So I'm gonna use a function called clamp, and what clamp do is it gets a value. So I'm gonna get first of all my vertical movement value, and I'm gonna clamp it between -10 and 10. So if this value is by any chance -50, I'm going to force it to -10. If it is -5, it's okay. But if it is beyond -10 or 10, I'm just gonna bring it back into this range. And I'm gonna do the same for my horizontal movement. There you go. Let's just do this. Great. And now I will, finally, I have the information, I have the data, and I'm gonna apply this information on my Seagull, on a component called transform. So Unity, the way games are divided in Unity is that your game have scenes, so you can think that each level in your game is a scene. Within the scene you have game objects, so everything in your scene is a game object. And the game objects have components. Components are building blocks of game objects. Let's think about Super Mario, right? So each level of Super Mario would be a scene. Each of the elements in the level, like Mario, each one of the Koopas and the brick blocks and the score and the clowns in the background, each one of these would be a game object. And Mario would have components like the jumping component, a component that detects when Mario hits a brick block, a component that detects when Mario dies and stuff like that. So every game object have a component called transform, which registers this game object position, rotation, and scale. And that's what you want to play around with, because we want to move our Seagull and want to rotate it. So I'm going to now add a node called transform rotate, and that is this one here. And the first thing I need to define is what I want to rotate, and I'm going to rotate the Seagull. So this, because this graph is attached to the Seagull, so this means the Seagull itself. Then the X angle, the Y angle, and the Z angle. And I'm going to get my vertical turn factor, and I'm going to apply it to the X angle.
Why the X angle?
Yeah, so that's a good question. I was hoping that you were going to ask it. So because if I select my Seagull here, there you go. You can see that these three arrows here, they represent each one of the axes, and the red arrow represents the x-axis. So if I want to rotate, and and the vertical movement of my mouse is called mouse Y. It's called input Y because it's on the vertical, right? So if I want to rotate my Seagull vertically, I need to apply this rotation on the x-axis or the horizontal axis. So it's a bit counterintuitive, but don't blame me. Blame any. So who have defined this?
Some guy.
Yeah.
Some 3D guy.
Some 3D guy.
A
yeah.
genius.
Don't
Probably
blame me.
Einstein. I don't know. I'll put that to him.
Okay, so once we've done that, maybe fingers crossed, if we run our game and we move our mouse, nothing's happening because we have something wrong.
Red.
No.
Yeah, so something's getting stuck.
Yeah, something's wrong in my console. Input axis, input Y is not set up.
So you need to go to File
Okay.
or Edit, Project Settings,
Enterprise settings, yeah, you have to
and you need to go to Input Manager
input manager.
and then check out what's wrong.
Oh, it's mouse X and mouse Y.
Yeah.
There you go. Shame on me. Oh, wait. Mouse Y and mouse X.
So, Input Manager, guys, just in case you didn't know, it basically tells you every input that you need to know about your Unity. So Unity transforms inputs from your mouse into, and there you go, it's working now. So it transforms the input, which is basically wherever you press a key down, whenever you move the mouse, into an actual function to use in the code. So you always need to make sure that everything's written correctly from your input manager and put straight into your code in the correct type or namespace.
Yeah. And it's working. There you go. If I move my mouse up and down, my Seagull just looks up and down. If I go left, right, it just goes left, right.
Something's wrong. This guy doesn't seem to be a flyer.
Easy, Jermaine. We'll sort it out soon enough. Okay, so now we have our mouse input making the Seagull rotate. So what we're going to do now is going to get our W input and make our Seagull move forward, right? And to do that, I'm going to create I could do this on the same graph, you know, but I'm going to do it on a different one, just to, you know, good practice, separate things, make it clearer for people to see. So I'm gonna add a new script machine to it. There you go. And I'm gonna create a new graph. I'm gonna call it, what I call the first one again? Rotation controller. So I'm gonna call this one movement controller. There you go. And again, I have an on start and on update. I don't need on start. I'm just gonna delete it. And on update, I'm gonna get another axis, and the axis I'm gonna get now is called vertical. And since Jermaine mentioned the input manager, just to show a little bit more in detail, I'm gonna go back to Edit Project Settings. So input manager, and you can see there's a whole bunch of axes already set up. We've used mouse X and mouse Y. We also have like horizontal and vertical. I'm using the axis vertical here. If I expand, I can see more details about it. And we can see that for the vertical axis, we have W and S as positive and negative buttons. So that's why we're using this vertical axis, because I want to make the Seagull fly forward when I press W. I don't want to make it fly backwards when I press S though, but we're going to sort it out. Now, as we did with the mouse rotation, I'm going to get multiply, and I'm going to multiply my vertical input with, I should create the speed variable on this one, right? Look at that. Speed, float. I'm gonna set the speed to 1, just so we just so you know, just so see what happens. And then get graph variable. I'm gonna get the variable speed, multiply, and I'm gonna clamp, and now I'm gonna get this result, and I'm gonna clamp it again between 0 and 1, because if I allow a value that is lower than 0, that means that our Seagull is gonna fly backwards. I don't want to. Shouldn't fly backwards, should it?
No.
Yeah, it's too much.
I've never seen a bird fly backwards.
Too much of an advantage for the Seagull. And now I'm going to finally get the oops, the transform translate. Is this the one? No, it's not this one. I should get an X, Y, and Z. Oh, no, yeah. No, this one. Yeah, I'm just forgetting a step. Sorry. So I'm gonna get this result, and I'm gonna create a vector 3 out of it. No, not this one. Delete. Vector 3. Create. There you go. X, Y, Z. And I'm going to get this value, and I'm going to put it on the z-axis. So, because I want my my seagull to fly forward, and forward is based on the z-axis at Unity. So I'm gonna get the speed that I've calculated here, gonna put it on the z-axis, and I'm going to call transform.translate, which makes the position of our seagull just change, and I'm going to apply this new position to the seagull so it flies. Let's see what happens now. Again, fingers crossed. Let's see if this works. We're still rotating up and down, and if I press W, whoa, there we go.
This guy is quick.
Yes, a little bit too quick, right?
Hyperdrive.
Yeah, look at that. Oh my god, it crashed into the floor. Okay, so let's reduce the speed. How about, I don't know, 0.1. Let's see how it goes now. Too slow?
Yeah, it could be a bit faster.
I guess, right? Okay, let's try 0.5. Let's see.
Let us know in the chat how fast should this guy go on average?
0.5 too fast.
It kind of looks like he's going about 30 miles an hour.
Okay, let's do 25. 0.25. I think that's good.
Yeah, that's
Yeah,
pretty sweet.
yeah. 0.25. Yeah, again, let's keep it like that, and you know, at any moment we can change it and make it faster, slower, etc. Is there anything wrong with our seagull? What do you think?
Yeah, something about, I don't know. I usually see birds flap their wings.
Right. Yeah, I knew there was something missing. Okay, so as Jermaine had pointed, our bird is not flapping its wing, right? And what we're going to do now is we're going to apply an animation on the seagull. And again, this seagull came from our browser. If we look here at seagull on Anything World browser, and here's the seagull. And this seagull, is this the one? It is, right?
Yep.
And this seagull, you can see by this play icon here in the top left, it is animated. So again, as I mentioned, Anything World's AI agent, it not only rigs the model, we got this static 3D seagull model, we rigged it, and we also created a set of animations for it. So if I go on my seagull, I can see here that it has a couple of animations that was provided by it, that was provided to it by Anything World, which is fly and glide. So this week we're going to make our seagull fly. Next week, when we improve a little bit on the input, we're going to make it glide as well. But today we're going to make it fly. So how we're going to do that? We're going to go back to my seagull, and I'm going to add a component, another script machine. This one I'm going to call animation controller. Again, on start and an update, but now we're going to use on start. And on start, I'm going to add a node called animation play. There you go. Oh, not this one. Animation play with the animation. There you go. Gonna drag this guy here, and I'm going to use Where is the?
I think you need to apply this script on the rig, or maybe
Or create a variable.
yeah.
And so type. Okay. So what I'm doing here is just to get a little bit more into detail. So when I import this model from Anything World, I have this game object here that contains this animation component. And I was saying components are the building blocks of game objects. The animation component, as the name says, handles the animation of our game objects. So our graph, it needs to know where this animation component is. So what I'm gonna do, not this. What's that?
Animation clip.
No, it's not. It's not the animation clip. It should be the animation.
Try yeah.
Sorry, game object. Oh, let's see if we can.
Yeah, click no, because the rig is just I think it's an empty scene rotated.
What's that?
Click on scene rotated.
No, but that's not where the animation is. Wasn't this?
Click on the rig and you see on the inspector.
Okay.
On the animations there. Yeah. All right. So it's on the rig.
Yeah, it's on the
Try and create the script on the rig component itself, just to see if that will work.
Oh, right. Yeah. Okay. So I got to delete it from here. And let's. Here we can do the animation controller. And then we can do this and fly. I'll explain in a second what we're doing here. Just want to make sure that it's going to work first. Let's see. Hey,
Sweet.
there you go. Okay, so
He's alive.
it's more of a hummingbird, right?
Yeah.
So as I was mentioning, so you have the animation component on the rig game object. I've created a script machine within this game object, so you could use the animation component in it. And all I'm doing here is saying, when the game starts, just start playing the fly animation. And there you go. Now we have fast again. Have I? Oh, it haven't saved the speed. Wait. Why is it so fast?
Yeah. Good question. I don't know. Sometimes I did have this issue before when I was test running this.
No. Yeah.
Sometimes the speed just gets a bit.
No, 0.25. Yeah, I know I was wrong. So yeah, let me. So this is the speed that we're not using anymore. There you go. Now it should be right. Let's see. There you go. Great. Our game is looking
Nice.
amazing. We're flying, and we're going up and down. Can fly through the trees, crash the ground. That's great. Okay, so, and of course we're not flying backwards. If I press S, nothing happens. So, we have the basic input. Great. Again, as I said, we're going to improve on that a little bit. Like, I want to, when I press Shift and W, I want my seagull to fly slightly faster and to use the glide animation instead of the flapping.
What about barrel roll?
Ooh, barrel roll, right?
Anybody else got any flight pattern ideas? Any cool
Oh yeah,
flight animations that we can add?
barrel
Let us
roll.
know in the chat.
Barrel roll is a good one. Oh, but we cannot use barrel roll because it's a seagull, it's not a fox. You
Yeah.
got the reference? That was a good one, right? There you go. Okay, so now I'm going to pass it to Jermaine, which is going to work on setting up the environment for our game. So he's going to add some cool 3D stuff to the environment. He's going to talk about what is already in the environment, the clouds, the trees, etc. But now Jermaine is going to take over. So let's switch our positions. We're going to use this? Or okay.
What do I press to turn the mic back on? What do I press to turn the mic back on? Is it still on?
Just go to home monitor.
Which one?
The home monitor. Over there. Oops, sorry.
Oh,
Yeah,
okay.
there you go. And we're back.
Hey, that was seamless. Can you guys hear us? Or do I have to turn this? Do I turn this one on?
Oh no, I think you should be fine.
Everybody's cool? Everybody
Just
hear me?
anybody confirm that you can hear Jermaine.
Great.
Okay, cool.
Welcome back, guys. Yeah, you can do. I'm seeing some cool stuff in the chat. So it can do a 360 when you press shift to make it go faster. That's cool. Anybody else got any cool ideas for how we can animate this guy? This guy is looking already pretty mobile. You can go through the trees. Let's see how, like, if I can go into clouds. Ooh, there you go. So yeah, let us know, and we'll get working on that stuff for next week. So anything you input in the chat in terms of ideas, we'll try and do a live brainstorm and come up with some cool stuff that we can add to this game. Because right now it's already looking pretty awesome, but it can do with a lot of work as well. So we can make this epic. It's at awesome level right now, but it's not epic yet. So I'm gonna go through a quick breakdown of what I did with the scene so far. So everything that you see in this scene, apart from the sky, is from Anything World. The sky is actually from a cool plugin that I can get, that you can get from the asset store. So if I go into, is it this one?
Yes, that's right.
There you go. All right, cool. So if I go into, I'm hacked into Gordon's account. He doesn't pay me for that. But if you go into the asset store, there's an asset called Customizable Skybox, and it's really cool. And the best part about it is it's free. So no matter how much money you got, you're definitely getting this. And it basically gives you a gradient that makes the sky look nice and colorful. You change the different types of colors that you want. You don't have to stick to the basic setup that you get from anything, not Anything World, but from Unity. Unity usually gives you this, which is pretty dull and pretty bland, and not that customizable. So what we're using is the customizable skybox, which is one of my favorites so far. The next thing I did to this scene was I went to window, and I went to general.
You look for the lighting settings?
I was looking for the lighting settings.
Yeah, it's on rendering.
Rendering, lighting. There you go. I already forgot. But anyway, so you've got lighting, this lighting tab on the right where your inspector should be. You can create a new light setting. Next thing I did was I turned off that really annoying skybox look, because look at what you get here. It looks all yucky and not so great and very too serious, almost Art Deco-y color style. I don't like that. So I just go to a straight up solid color, and I change it to white, so everything looks kind of shiny, new, and cartoony, because we're going in for a not too serious look. It's not the Dark Knight, it's just the bright seagull. So we're gonna stick with that. Skybox material, I used a stylized sky. All I did was, like I said, download it, import it, and if I go to this customizable skybox folder that you get under your project settings, you can go and open stylized sky folder, click on shaders, and then you can right click, create on the shader. This is a cool thing about shaders. Right click, create, and then create a material and give it whatever you name you want. Let's say I want this scene to be in night, so I'll do night time, and then I drag this into my stylized sky slot in the environment. I can go back onto this, go into my inspector, and change this into like a dark purpley sort of night sky. Bring the brightness a bit down. On the bottom again, I just make this nice and dark. And so now you've already got like sort of seagull at night. So this could also be an idea for a different level, maybe something at night, and then you can adjust the lighting as you go. Another thing that I like to change to get this cartoony effect is when you download the render pipeline, the universal render pipeline, there's a lot of different features that it doesn't really jump straight out at you. So I'm going to let you know some of the hidden secrets of the render pipeline that seagulls don't want you to know, but I do. So because I want you guys to, you know, get better at modeling, lighting, and just, you know, straight up making cool looking scenes. So if I click on this asset, which is new universal render pipeline asset, you can also create your own one. So you can go to right click, this is a right click, create, rendering, universal render pipeline, settings asset, and you've got a load of settings here, but I usually go to URP asset with universal renderer. You get something like this, and what it allows you to do is control stuff like the normal and depth bias, which is right here. You can also control the cascade count, which sort of adjusts the amount of splits that you have in your shadows. So shadows are important because they make everything look a little bit more realistic or cartoony, depending how you want. And if I adjust this normal bias, you get this really annoying and creepy bleeding effect that you're seeing here. So I don't like that. So that's the first thing I change. Then you can also choose the depth bias. And then if you adjust these in tandem, you get to see what the depth bias does a bit more. Not too much. But I usually like to keep the normal bias very low, especially when I'm doing these cartoon style scenes. You can choose a post-processing setting. I usually use like sometimes high dynamic range, but for this I don't really need to, so I'm just going to use a low dynamic range because it's a cartoony scene. And the last thing I did for my lighting settings is I went into lighting and I turned off the reflections. So these are the reflections that you get from the skybox, and I didn't want any real reflections because I feel like it doesn't blend that well right now. I could make more tweaks to my skybox, but I'd rather just go and keep it really simple and turn off the reflections. So let's get back to where I've lost it now.
I think it look much better without the reflections too.
Yeah, so let's turn this off. So let's just go back to custom.
There's something that it took me a while to figure out, and I started Unity, and I thought it was an issue. It's like, notice the shadows, and when you move forward, the shadows show up. See?
Yep.
Is that an issue? Is that how my game's gonna look like?
No, that shouldn't be how your game's gonna look like. So one of the issues is, I think is this a dynamic clipping issue? No, it's not a clipping issue. So if we go into our game, this is something that you can see in the game as well. To be honest, this is the first time I've had this issue.
I think that's not an issue. That's just the way the editor shows the shadows.
Yeah.
When you actually run the game properly, that's not gonna happen. So.
Yeah, it does have something to do. It looks like sort of shadow clipping or something like that.
There's a place where you set this configuration. I'm going to look here real quick and try to find it.
Cool.
So I didn't want it to put you on the stall or anything. It was just.
No problemo. So one of the other things is fog. While Jay looks that up on an environment setting, so you can add fog. I didn't choose to add it for this scene just because I just didn't want to add any fog. I wanted it to just be a bright scene with no real atmosphere. But without the atmosphere, it still looks pretty cool. So you can add a fog. You can not add fog. It's up to you. I'm gonna stay away from the fog right now because I don't want to play with it at this point. Next step is, and then we're gonna go back and change this sky back to the original sky that I had. So go to my lighting and go here, and let's change it back to daytime. All right, cool. So what we want to do with Anything World is, how did I get all of this stuff set up in the first place? So the first thing I did was create the road. So I just typed in road in Anything World. I found this road block asset. Oops. So when I bring it into my scene, oops, there you go. Get rid of this. Put this one up there. You get a really small road, which is actually not to scale, but that's something we're working on. And you can just duplicate this. So what I did is I just duplicated this road. As you can imagine, you could just right click, duplicate. And you don't just have to duplicate one at a time, but you can also duplicate 2s and 3s and 4s at a time. So I would make like, let's say 4 duplicates and space these out. And you just go back, space this out. And then I just grab them all at once and I duplicate those all together. The next thing I did was I created an empty and I called it road full or road. And I just dragged these road blocks into this empty and then I rescaled this empty to get to the size of my road. So it's that simple and that quick to create like a quick street. If I wanted to do like a turn or a T junction in the road, I could have done that. But we're just going to delete that part. For this floor on the outside, it's literally just a plane. So you can go 3D object, add a plane. And then I just rescaled that plane using the scale tool. You know, you can make it as narrow, as wide as you want, and as big as you want. But I based all of this off of the trees that you see in the scene. So these trees are added again using Anything Else. So you just type in tree. And I added like about 3 versions or 3 different tree variants. Once you add it to your scene, it shows up right in the middle, which is perfect. And I scaled my road based off of how big this tree was. One thing I didn't like about the tree when it came in was the color. So you can just go into the inspector and you could actually just click on the actual object and change and make the colors brighter. So you've got the green material for the tree, so I'm just brightening this up. And you can see on these ones out here, I forgot to make this dark green a bit brighter as well. So
I think it was nice. It added
a bit of variation to it. Yeah.
Yeah, I think it was good.
Okay, so I'll make it just a little bit brighter than it was originally.
But you know, you're the artist.
I'm the artiste.
Exactly.
So, there you go. So now I've got a whole bunch of these different trees, and I've used the same principle I used with the road, duplication, and just spread them out. The last thing I did is preempting what's going to happen with these trees. So now these trees have all got colliders on them. So what I did was I used the same grouping method that I showed you with the road. I maximized all these trees. I shift clicked on all of them, and then I added a component and I just typed in collider. And I used a sphere collider. And once you add the sphere collider, you can also, let's say if I get like a set of these trees, you can also control simultaneously the radius of these colliders, which is perfect. So we're going to need that later, probably next week, when we start making the tree edible. So the next step was just doing the same thing, going to Anything World, finding some clouds, dropping some clouds in. And also what I'm going to do lastly is add some buildings. So I'm just going to create empty, type in building, and I'm just going to center this. So let me just go into inspector, 0, 0, 0, and let's add some buildings. So let's just type in building. Tell me guys what you want in terms of buildings. Do you want apartments? Do you want roller coasters? Do you want, what type of buildings do you guys want to see in the chat? I can't see the chat right now.
Let's click on the
Is it this?
yep, over there is fine. There you go.
There we go. Can you add some Roblox characters? Yep,
Yeah.
you can add some Roblox characters. I'm gonna add first my apartment. We can also add some people walking up and down the street. We can add some cars. let us know what you want in this scene. So we've got our first building, our apartment. I like to have a block of apartments. So this guy like popped up perfectly on the side of the road. So let's
This
just
appeared exactly where it's supposed to be.
exactly. So that's it's all done on purpose.
Exactly.
Okay, so let's add some more. Maybe add a cutscene. I'm seeing. Can you make customization store? Yeah, that would be cool. Maybe you can customize your seagull. That'd be pretty sweet. That'd be a nice game mechanic. We're going to be taking all of these down, so put them in the chat, guys. Let us know what you want to be added, and we'll take these inputs into mind when we're coming in next week with some updates. So yeah, we're going to have some more buildings. I like to have a variation of size as well, so we just add these sort of distance buildings. It doesn't have to be too detailed. We just want some low poly buildings, and we can just stick next to each other. So we've got some small ones there. Roblox characters. Let's see if I can find anything to do with Roblox. Alright, so a lot of robots are coming up.
Oh, this blue, second row, first one left.
This is a Roblox guy.
It is.
There you go. Alright, so this guy's actually going to be a giant robot Roblox.
Nice.
So this is going to be like a, I don't know, what can he like a mascot for the petrol station or something like that?
Yeah, nice. Yeah. In front of
So
the
we're gonna add a petrol station and this giant guy, Roblox guy. So let's just go, boom, bam. Maybe he's gonna have some like hidden food or like a hidden treasure next to him or something like that. So let's go, petrol station. Yeah. So tell me, guys, do you guys want to see? Oh, we've got a massive petrol station here. Might have to like bring this down. Do you guys want to see anything in terms of like secret things to get, like bonus assets or anything like that? Let us know.
What would be a secret treasure for a seagull?
Yeah, what would a seagull want to find? Like, obviously, food is the first thing, but maybe a secret Gordon. I don't know. Maybe a secret Seb. So what can we actually put in this scene to add? Please put it in the chat. It would be great to get some of you guys' feedback.
We'll definitely need to add Gordon eating chips, and when the seagull eats Gordon and chips.
Yeah.
It needs to have like a Final Fantasy fanfare.
Alright, so for this, I'm gonna just get rid of some of that street because we didn't need it. So
this is
you can actually open up and edit some of these models.
Yeah, what you did here,
if you didn't know,
it was pretty cool because you got a model from Anything World and you can customize it. You don't have to use it as is.
Exactly.
Right? Yeah.
That's one of the big treats of using Anything World. Some of these models come customizable, and you can actually just like change the textures, change anything really on the fly for most models in terms of textures. But for this one in specific, because it had a hierarchy of different assets, you can actually just go in and take in or take out assets. So now we've got a little more of an interesting looking road, nice. A mascot. Let's have a little fly through and just see like what it looks like so far.
What about a school? So the
school, because yeah, exactly. We need these seagulls to be smart. You can't just be. So now you got like us flying around these things. Looks even more interesting now that you've got like the flight patterns in there. So there's one last thing.
It's already so different. It's so much livelier with buildings, right?
Exactly. So there's one last thing that we want to add, and that is a particle system for this bird. So
yes.
So this is something I've been putting off, but it's time to tackle my demons. I'm joking.
And this is
particle system.
I don't know how many times I said to Jermaine that I love the particle systems because it gives such a nice effect of flying to the seagull. And me being a dumb programmer that can barely draw a stickman, this is something that I always love.
Cool. So we've got these particles shooting up in the middle of nowhere. We want them to be on the wings of the bird. And let's get up here. Let's bring these over here. So these particles actually look pretty big. One thing, instead of like moving this around and trying to line it up with the seagull, so what I usually like to do is I will go straight to my seagull in the hierarchy, if I can see it. There you go. And I'll go and go on the drop down, go in the body drop down, and let's go straight to the wing right, the right wing. That's not my political alignment, it's just it's just the wing choice that I wanted. So
you're going far right.
Far right, yeah. And then we're gonna go far left. So let's copy component.
And this here that you're expanding, this is the rigging, right? This is the way that Edific World have set up the rigging on this 3D model.
Exactly. So you've got access as a user to the rigs. So you can paste these component values. I think it's setting it to where it was, not where it is right now. So we actually are gonna have to just go in and put this straight on the wing of the bird. So right now you can see the bird is actually smaller than the particles. The bird is right here, the particles are right here. So the first thing I did was I changed the particle size, start size to 0.0001. So I can see my bird first, and then I aligned these particles with the wing. Now the next thing I did was I attached the particle to the wing, and then I started making the particle actually work. So particle system actually work. So instead of 0001, let's just do 0.01. And we can actually see the particles now just floating off a bit. What I want this to be is a particle that uses a rate over distance instead of a rate over time. So I'll go into my mission drop down. I'll change this to 30 in the rate over distance. This basically means it only emits when I move it. So now you can see it's emitting only when I move it. So that's perfect, because when the bird moves, that's when you want the particles to actually move. The next thing you want to do is change the start lifetime. What I'm going to do is quickly get my cheat sheet. And you want to change the start lifetime to 1, and you want to change the start speed to 0. So you can't see it right now. What I'm going to do is I'm going to make this particle just a bit bigger so you guys can see it on the screen. 0.1. Also what I'm going to do is I'm going to change the simulation speed to 1 and the maximum particles to 5,000. We're going to next go to our we're going to go to our shape and change that into a sphere. So we've got a shape here. I'm going to change this from a cone into a sphere. We're going to change the radius of the sphere to 0.001. Let's move that around. So far still nothing. We're going to go for a loop and change the arc mode from loop to, yep, we're going to just keep it there. The next thing I want to do is color over lifetime. So this basically means as it goes over its lifespan of the particle, I want it to fade away. So I want it to go from alpha 255 to 0. So it's going to start off bright and then end up not showing up. And I'm going to just change the alpha in the middle to about like 156 or something like that. And then the last thing I did was size over lifetime. So size over lifetime is similar to what you saw with color over lifetime. Once you tick that box, you can click on the arc, and I want it to just go big on the left and small on the right. So over time, it just gets smaller. And in the renderer, I'm going to make this particle, I can choose what type of particle I want to use. Right now I'm going to use the default sprite. And let's see, start size, let's change it back to 1. 0.1. And start lifetime. Start lifetime, or was it start speed? Yep. Okay, so it should be playing. For some reason I've lost the particle, so oh sorry. Some reason my rate over distances didn't get entered. Alright, there you go. So you can now see, like, when I play it, when I move it, it plays. But we need it to actually create a trail once it's moving. So what I'm going to do is I'm going to attach this to the right wing. And then I'm going to just move this straight onto the right wing. And then we're just going to duplicate this particle effect over to the left wing as well. So there we go. It's a really big particle right now. And I need it just to be 0.001. So let's see how big it's going to be now.
Nice.
It's a bit. Still really big, right? There you go. Okay, so I've got my right wing particle set up. This should move with the rig. And let me duplicate this and move the second one over to the left wing. And also attach this to the left wing as well. So I just drag this onto the left wing in the hierarchy. And now when I play, it should. Alright, so we've got the animations on there, but the trail is just sticking in one place.
And on the left wing, you're attached to the wrong game up to on 7, so that's why it's moving up.
There you go. Alright, so
But it's not. Yeah. There you go. But it's still not. Yeah.
okay, so we've got the particles playing, and we've got the particle on the wing. We just need that trail effect to start happening. So size of a lifetime, color of a lifetime, shape. Let's change it to random. Let's change this to world. There you go. Alright, so the one thing I missed was simulation space. Change it to world instead of change it to local. So let's go to the other one and change it from simulation space to world instead of local. And you should get your trails now. You can use this for anything as well. You can use it for, so now you get this pretty cool flying effect and these cool trails with the bird. So now what I want to do is I just want to sort of consolidate that and tweak the parts, but that's generally how it's done so far. So I'm going to save this right now. So that's generally how it's done in terms of creating a stream of particles to make it look a bit more fancy. And let me just move some of these particles over here.
I mean, one of the joys of not being able to do anything art related at all is that stuff like that makes me so happy. It's just, you know,
Yeah, something about just
So fun,
seeing
isn't it?
seeing it
Yeah.
evolve into
There
something.
you go. Look at that. And it gives a nice movement feeling for the seagull. Maybe
Exactly.
something
It's actually way better than when I tested it on my own.
maybe something we can think about, but that's for the other session. We're way too long this session already.
Yeah.
So maybe disable the particle system when the seagull is not moving. You know?
Yeah.
Maybe something that we can add.
That's something we can do with code. You can play it on like on key down.
Yep.
I think that's what I did before. Like I tried it on key down,
Yeah.
and then that's a pretty good solution.
It's going to look much better.
There you go. So now these particles look a little bit more. Just look so cool.
It looks really nice. It gives a nice movement feeling for the seagull.
Exactly. It's like a nice ribbony effect.
Yeah. Great. I think we can wrap it up for today.
Sweet.
It's been more than 1 hour. It's great. Thank you for everybody that stick around us. One thing I forgot to mention is that I told you that this is going to be a session. The camera stopped working, but we're still live, so that's good. We'll be sharing this project. So tomorrow I'm going to put this in a Bitbucket repository, so you can download it and play around with it. And if you do anything cool with it, just share it with us on Discord or on Twitter. Yeah, I think that's it, Jermaine. Any final remarks?
Yeah, that's pretty much what we got for today. But thanks guys, thanks for tuning in. Hopefully you guys can take this recording and use it in your own projects.
Yep.
And yeah, we can't wait to see what you guys can do.
Yeah, Jermaine, thank you so much for this.
So and thanks to TJ.
Thanks everybody, and see you in the next stream. Bye bye.
Take care. Bye guys. I don't know how to turn this off.
Press stop streaming.
So